Hello everyone, I am Dr. VRAO. Today I am here with another concept in electrochemistry, that is determination of equilibrium constant by Nernst equation, right? What is that? Determination of equilibrium constant by using Nernst equation. Right? Determination of equilibrium constant by using Nernst equation. I shall try to explain the determination of equilibrium constant by Nernst equation with the help of Daniell cell. We know Daniell cell. In which zinc rod dipped in zinc sulfate solution, in which Daniell cell has two compartments. In which zinc rod dipped in zinc sulfate solution. This is the zinc rod, and copper rod dipped in copper sulfate solution. This is called, zinc sulfate, right? This is zinc electrode, and this is copper electrode, and this is copper sulfate solution, and these two are connected to with a salt bridge. And these two electrodes are connected to voltmeter or ammeter, right? This is Daniell cell, right? And we learned from the last classes, that is, we know that when cell is functioning, the concentration of Zn+2 ions increases due to the oxidation of zinc. Zinc undergoes oxidation, that is, zinc solid undergoes oxidation. So, due to when the cell is functioning, the concentration of Zn+2 ions increases in the oxidation compartment, and the copper Cu+2 ions undergo reduction, that is Cu. This is aqueous and this is solid and this is aqueous, right? So, Cu+2, the concentration of Cu+2 decreases, right? So, after some time, and one more thing is that corresponding to this concentration polarization means whether it is either it is increase in concentration or decrease in concentration, right? Concentration polarization means either it is increase in concentration or decrease in concentration, right? When cell is functioning, the concentration of Zn+2 ions in this compartment increases, and the concentration of Cu+2 ions in this compartment decreases. Corresponding to this concentration polarization, voltage of the cell varies, right? Corresponding to this concentration polarization, voltage of the cell varies. But after some time, we can find that there is no change in the concentration of Zn plus 2 ions as well as in the concentration of Cu plus 2 ions, right. But after some time, when cell is functioning for some time, there is no change in the concentration of Zn plus 2 ions as well as no change in the concentration of Cu plus 2 ions. Okay, at that position, voltmeter gives a 0 reading. Voltmeter gives a 0 reading. When the voltmeter gives a 0 reading, that indicates equilibrium. And that equilibrium can be represented with a chemical reaction, that is redox reaction, that is taking place in the Daniell cell. That redox reaction is zinc solid plus Cu plus 2 aqueous, right. There exists equilibrium, that is zinc undergoes oxidation Zn plus 2 aqueous plus copper solid, right. So, and that whenever that voltmeter gives 0 reading, that indicates equilibrium, and that equilibrium can be represented with a redox reaction that is taking place in the Daniell cell, and that redox reaction is that, right. And this is a reversible reaction. And for that reversible reaction, we can write equilibrium constant. So, for that reversible reaction, we can write equilibrium constant, right. Equilibrium constant is ratio of concentration of products to concentration of reactants, right. Then why I could not I do not write the copper and zinc, because these are metals, solid metals, and we consider the solid metals concentration as unity, right. So, K is equal to concentration of Zn plus 2 by concentration of Cu plus 2. This is the equilibrium constant, and that we are going to calculate from the Nernst equation. What is the Nernst equation? Nernst equation is E cell is equal to E naught cell minus 0.059 by n log K, where K is equilibrium constant expressed in concentrations, right, Kc, right. But when the cell attains equilibrium, this voltmeter gives 0 reading, that is EMF of the cell is 0, right. That means at equilibrium, EMF of the cell is equal to 0. At equilibrium, E cell is 0. Why E cell is 0? When cell attains equilibrium, this voltmeter gives 0 reading, that is EMF of the cell is 0. That is, when cell attains equilibrium, that indicates the EMF of the cell is equal to 0. Okay, E cell is equal to 0. So, E cell 0, then substitute E cell 0 and E naught cell minus 0.059 by n log Kc. Alright. So, when this is equal to 0, and then we can write E naught cell equal to 0.059 by n log Kc, right, log Kc. That Kc is concentration of Zn plus 2 by concentration of Cu plus 2. And in the next step, we can write this as n into E naught cell by 0.059 n is equal to log Kc, right, log Kc. Then in the next step, in this next step we can write this, we can write this logarithm, we can apply this logarithm to this side, that is Kc is equal to 10 power n into E cell minus E cell by 0.059 is equal to Kc. So, Kc is equal to this is right. Kc equal to 10 power n E cell by 0.059 equal to Kc, right. Okay. So, Kc is equal to 10 power n E cell by 0.059, or more simply we can write as E naught cell is equal to 0.059 n, 0.059 by n log Kc, right. So, we can calculate the equilibrium constant Kc from next equation, provided if we know the number of electrons transferred. We know that number of electrons transferred for this reaction, that is 2, but we should know the E naught cell, that is E naught cell, we should know the E naught cell value. Okay. By knowing the E naught cell value, we can find the equilibrium constant of the reversible cell reaction, right. So, let us try to calculate the equilibrium constant for this Daniell cell, right, for this Daniell cell. Okay. For this I want to erase this, right. So, we know that standard EMF of the Daniell cell is 1.1 volts, right, 1.10 volts standard EMF of the Daniell cell. We know this standard EMF of Daniell cell is 1.1, that is 0.76 plus 0.34, that comes out to be 1.10 volts, right. So, standard EMF of the Daniell cell, we know that standard EMF. Let us calculate the equilibrium constant from that. So, E naught cell, what is the formula to calculate equilibrium constant? E naught cell is equal to 0.059 by n log Kc, right. We know the standard EMF of the Daniell cell, that is 1.1 volts and 0.059, and the number of electrons transferred in the Daniell cell is 2 into log Kc, right. In the next step 2 into 1.1 by 0.059 is equal to log Kc, right, and this comes out to be 37.288, this fraction comes out to be 37.288 is equal to log Kc. Then Kc equal to 10 power 37.288. Okay, this can be written as 10 power 37 plus 0.288 is equal to Kc. Okay, and in the next step Kc is equal to, we can write this, we can apply this 10 to 10 power 7 10 power 37 into 10 power 0.288 is equal to Kc. From logarithmic rules we can apply this 10 power to 37 and 0.288. Okay, this is 10 power 37. This can be taken as 0.3 because 2.288 which is nearly equal to 0.3 and Kc. Okay, 10 power 37, 10 power 0.3, log 0.3, log 2 is equal to 0.3. Okay, so 2 equal to 10 power 10 power 0.3. So, 10 power 0.3 is equal to 2. So, this is equal to 2 is equal to Kc. So, Kc is equal to 2 into 10 to the power of 37. This is the equilibrium constant that for this reversible cell reaction that is taking place in redox Daniell cell, right. So, equilibrium constant. So, we can calculate the equilibrium constant for the any cell reaction or any cell reaction, provided we should know the E naught cell value. Okay. So, therefore, let me conclude the one point, that is we can calculate the equilibrium constant provided E naught value, E naught cell is known, E naught cell is known, right. So, this is all about determination of equilibrium constant by using Nernst equation, right. And one more important point is that for this reaction, by this redox reaction, cell can generate electrical energy, that is cell is doing some work, the maximum work done by the cell or the electrical energy produced by the cell is equal to electricity into EMF, right. Electrical energy produced by the cell or electrical energy or total work done by the cell or maximum work done by the cell, W max or total electric energy produced by the cell, that is also equal to maximum work done by the cell. So, maximum work done by the cell or maximum work done by the cell or electric energy produced by the cell is equal to electricity NF into EMF of the cell, EMF of the cell. So, maximum work is equal to NF E cell, and maximum work and electric energy of the cell, maximum work or electric energy of the cell, electrical energy of the cell is equal to NF E cell, and maximum work or electric energy is equal to decrease in free energy, that is NF E cell is equal to decrease in free energy, So, NF E cell is equal to minus delta G. Okay. For example, if all the species involved in this redox reaction are maintained at unit activity, then E cell becomes EMF of the cell becomes a standard EMF of the cell. Okay. So, E cell equal to E naught cell when all the species involved in this redox reaction are maintained at unit activity, then EMF of the cell is equal to standard EMF of the cell, right. So, E cell is equal to E naught cell. So, we can write NF E naught cell is equal to minus delta Z naught, right. These are the two most important relations, right. And we know that from thermodynamics, delta G is equal to minus RT ln K, delta G is equal to minus RT ln K, right. And we can write that delta G is equal to minus 2.303 RT log K, right, log K. From this we can also write delta G naught also, right. So, delta G is equal to 2.303 RT log K, right. These are the three most important formulas by which we can solve number of problems, right. So, this is about determination of equilibrium constant by using Nernst equation, right. So, let me conclude this lecture. In the yesterday's class, that is EMF of hydrogen electrode, we should take E naught cell as 0, then we can calculate the EMF of the single electrode. Okay, but in this lecture, that is determination of equilibrium constant, from Nernst equation we should know E naught cell value, that is standard EMF of this cell should be known for the determination of equilibrium constant. Okay, I hope you all understand this lecture. If you are really like this lecture, please extend your support by your like, share and comment. Thank you. Thank you for watching.